Hello students, and we are ready for page 6 of your summer packet, but I realize that I forgot to do these 3 graphs that were really to go with page 4, but we're at the top of page 5. So let me do these first. I kind of referred to this one already, right? I wanted you to think of, if you think about just the square root of x and what that graph looks like, this is the square root of x, and the square root of x minus 2 is this same graph moved 2 units to the right. So instead of having the starting point at 0, 0, it's moved over to 2, 0, and then is the top half of the parabola, sideways parabola. So the domain is going to start at 2 and go on forever, and the range is still always 0 or positive. I'm going to skip K for a minute, and I'm going to go to L. This is an absolute value graph. So y equals the absolute value of x looks like this, with the vertex at 0, 0. Right, over here I should have drawn the square root of x, looks like that. The kind of elbow point at 0, 0, and it's moved 2 units right. Y is equal to the square root of x minus 3 minus 2 is this absolute value graph, moved left 3 and down 2. So instead of being at 0, 0, left 3 and down 2. Something like that. Now, this graph is not one it's not one of your regular common functions that you studied in Algebra 1, Algebra 2, or Pre-Cal, but it does come up a decent amount in the second half of calculus. Before I graph it, I'm going to do some algebra and see if you can recognize it from there. Oops, I'm sorry, I forgot the domain and range. You can take the domain, the absolute value of any number whatsoever, and the range starts at the lowest y value and goes on forever. Alright, so graph K. I'm going to get rid of the radical here by squaring both sides. Then I'm going to move the x squared over to the other side. From prerequisite classes, you are supposed to recognize that that is a circle with a center at 0, 0 and a radius of the square root of 4, which is 2. So 1, 2, 1, 2, 1, 2, 1, 2. Okay, that is not the graph I was given. Oh, sugar. Didn't want to erase the whole thing, gosh darn it. Remember, I took this equation and I manipulated it, and I got x squared plus y squared is equal to 4 as a center of 0, 0, radiates out 2, 2, 2, and 2. And I get a circle of radius 2. But that is not this equation. Because this equation, the original is a function. A circle is not a function. And most of our theorems in higher level math, well, in math, deal with functions. I can deal with the fact if I don't have a function, but it's super nice when I do have a function. So I want to solve this for y. In other words, I want to go back to this. So I get y squared is equal to 4 minus x squared. But then I take the positive and negative square root of 4 minus x squared. So positive 4 minus x squared is the top half of the circle. That's positive the square root of 4 minus x squared. The bottom half of the circle comes from negative square root of 4 minus x squared. Well, which equation did I give you in K? Positive square root of 4 minus x squared. This is a semicircle with a radius of 2 and a center at 0, 0. So that's y equals positive square root of 4 minus x squared. Can you tell me what the domain is? Right? It comes from the radius. X is between negative 2 and 2, right? I go from negative 2 here to 2. And how about the range? What's the lowest y? Right? This is negative 2 comma 0, and this is 2 comma 0, and this is 0 comma 2. So isn't the lowest y 0 and the highest y is 2? Right? Semicircle. Again, I've alluded to this before. We're going to take this semicircle and spin it around an axis and create a three-dimensional shape. Alright, so I apologize for leaving that off of the previous video. Now we're going to go to page 6. Page 6, if you look at page 1, your directions are simplify. Page 6, your directions are solve. That's different. Simplify is just rewriting an expression. Solving is finding an answer that generates equality. So notice that I didn't put everything in order here. I grouped all the quadratics and the inverse of a quadratic, which is a square root. I put those all together because I'm going to use similar math to work with all of these. From Algebra 1, you should have learned that when you have a squared term and a linear term, you have to get everybody over onto one side and set equal to 0. Right, I subtracted 14 from both sides. And then, no, do not use the quadratic formula. You don't have time in calculus to use the quadratic formula on very simple Algebra 1 factoring problems, because you have two things, two factors multiplied together, and they equal 0, there's only one way that can happen. The only way that can happen is if x plus 6 is equal to 0. The only way that happens is that x is equal to negative 6, or x minus 3 is equal to 0, which only happens as x is equal to 3. This is not a coincidence that x is squared and you get 1, 2 answers. A quadratic always has 2 answers. Sometimes those answers aren't real, sometimes they're not rational, sometimes they're the same number, but there's always 2 because the highest degree is 2. A classic mistake that kids who have not practiced their algebra, a classic mistake with this is to factor this expression here and set it equal to 14. But you're making up your own math rules here. If you have two things multiplied together and the answer is 0, you go ahead and tell me some way you're going to fill in these blanks without one of them being 0. But if you have 2 blanks to fill in and the answer is 14, are you telling me that the only way to make that happen is if one of the blanks has a 14 in it? I don't think so, right? I mean, hello, 2 and a 7. I can just show you that I don't have to have a 14. That's why you have to have 0 on the left side of an equation, and you have to have multiplication. If you have multiplication and the product is 0, then you know that one blank or both blanks or the other blank has to be 0 in order for you to multiply and get 0. One of them or both of them have to be 0. So let's use that thought process here, right? Same thing. You cannot factor right now because you're equal to 3. You have a quadratic, which means you're looking for 2 answers. Again, if you need the quadratic formula to get these answers, you can do it, and I'm glad. I want you to get the right answer, but you will not finish a calculus test. You have to be able to do this in your head without the box method, without splitting the middle term. All factoring is guessing and checking, right? I need the factors of the leading coefficient combined with the factors of the constant to combine by the rules of multiplication of monomials to generate the same result. So if you don't believe my factors are correct, then check it out, multiply it back. Now let's use our zero product property rule. You have 2 factors. 1 times 2, and the product is 0. That means that either 2x minus 3 must equal 0, or x plus 1 is equal to 0. Notice I didn't write that step out here. I didn't really need to. I could just see negative 6 would make this 0 and positive 3 would make this 0. This isn't as simple, so maybe I need an extra second to write it out and isolate x. And those are my 2 answers. If you take this x and plug it in here and follow the order of operations, you will get 3. If you plug in negative 1 here or here and follow the order of operations, you will get 3. If you plug 3 halves into here and follow the order of operations, you'll get 0. If you plug negative 1 into here or here and follow the order of operations, you'll get 0. Now I'm going to do this problem. Once again, I have a squared and a linear. Get everybody over onto one side. And factor. 12 and 3 have a common factor of 3. There's 2 x's here and only 1 x there. So I'm going to pull those all front. Notice I don't use the same thought process because I don't have 3 terms. I only have 2 terms here. So I pulled out the greatest common factor, and I got 4x minus 3 is equal to 0. And then again, I've got, 4x minus 1, is equal to 0. And again, let's use our zero product property rule. I've got 2 things multiplied together to generate 0. Therefore, either 3x is equal to 0, or it's being so weird, I don't know why. Come on, Ben, behave. 4x minus 1 is equal to 0. So that means x is equal to 0, or add 1 divided by 4, x is equal to 1/4. Notice I have a quadratic and I got 2 answers. A common error with h is to divide both sides by x. If you divide both sides by x, you lose one of your answers because you reduce all you're left with is solving linear. You'll lose one of your answers. So make sure that you don't divide by a variable until you are sure you will get both of your answers. General rule of thumb, don't divide by a variable. Alright, this problem can be done multiple ways, but remember, for calculus and taking an AP exam, I'm interested in helping you do problems well and do them quickly, because you're always going to be pressed for time on the assessments. I could square this out, move the 9 over, factor, and solve. But that would take much longer than undo the square with a square root. Undo the square with a square root. X minus 5 is equal to 3, or x minus 5 is equal to negative 3. Remember, when you're undoing a square, you have plus or minus the square root of 9. So the 2 answers I get are x is equal to 8, or x is equal to 2. Right? Add 5 to 3, add 5 to negative 3. Again, the clue should be a squared should give you 2 answers. So before I go over to this radical problem, let me try to clear up something that I know causes kids a lot of issues. And it all goes back to this word solve. If you're solving a quadratic, for instance, y is equal to, x squared is equal to 16. The question is, how many things can you put in for x, square it, and get 16? Well, there's 2, isn't there? 4 squared is equal to 16. And negative 4 squared is equal to 16. The very fact that you can have 2 different domains and give you the same range is why a quadratic is not 1-to-1. Negative 4 gets you 16, and positive 4 gives you 16. That is a different question then when I ask you to simplify, no equation, just simplify the square root of 16. There is only one answer to that. Simplify the square root of 16. I'm not asking you to solve or answer an equation. I just want you to rewrite this as 4, not plus and minus 4. The reason that is because the square root function is 1 to 1. Right? The square root function, this square root function has been moved to the right 2, down 8, and kind of stretch it up. It is a 1-to-1 function. The square root, when I put in 16, if I look at the function y is equal, right? Y is equal to that. When you put in 16, you get out of 4. Okay, so simplify a radical versus solving a quadratic. Solving a quadratic over here is why I had to put plus and minus 9. Now let me get to that last question. Solving a radical equation. I'm trying to get the radical by itself so that I can get x by itself. I want x by itself, so the first thing I'm going to do is undo addition and subtraction. I'm going to divide by 3. Which is not an integer. That's okay, don't freak. I'm going to square both sides. And then I'm going to add 2. Watch how clever I am with my adding 2. See what I did there? I added 2. That's 18 over 9. So that I have a common denominator of 9, and I can add my numerators. Notice that a radical function has only one answer, not 2. Put in one number for x, you get one number out. But when you have a quadratic, you can put one number in for x, square it, and whether you put in a positive or negative in for x, you square it, it looks like the same number before you multiply by 12, right? Now, these two problems I put together because they are both inequalities. Inequalities sometimes throw kids. The best way to solve an inequality is a combination of algebra and graphs. So, step 1. Graph this. How do I know? Can you graph this? How is this going to be equal to 0? And when I want you to graph, I don't want you to worry about the inequality. I want you to pretend it is an equality, and I want you to graph that. That is x squared minus 9. That's a parabola that opens down, that opens up, but has a y-intercept and a minimum of negative 9, two x-intercepts of 3 and negative 3.
How closer?
Do you see where this graph is greater than 0? Can you see it? That's what this is saying. When the question is, when is this graph above 0? Well, I see it. When x is less than negative 3, or when x is greater than 3. Notice I have two highlighted blue branches, and I have two statements. When x is less than negative 3, when x is greater than 3. Notice how simple that was for me to do, because I could quickly and easily graph x squared minus 9. That's what Algebra 1 and Algebra 2 and Pre-Cal were for. Now, let's suppose that, dropped the pen, that's what you should suppose. There it is. Let's suppose you didn't know what the graph looked like, because sometimes I'll give you an inequality and you don't know, and I don't expect you to know what the graph looks like. Step 2, if you need it, is your handy-dandy number line. Here's what you do. And this is only if you need it. Remember, I'm done with this problem because I recognize the graph and because I understood what it was asking me. When is the graph above 0? I'm done. I'm moving on. But if I have an equation I don't know or I'm unsure of, what you can always do is use your number line test. Still think about when the equation is equal to 0. What numbers make your equation equal to 0? So you have to be able to factor. Now, fortunately, this was already factored. Negative 3 makes that equation 0, and positive 3 makes that equation 0. Now, I want you to test numbers to the left of negative 3. Choose any number to the left of negative 3. For instance, negative 4, or negative 5, or negative 50. I don't care. Any number to the left of negative 3. Plug that number in back here. What is negative 4 plus 3? What is negative 4 minus 3? And what is that product? Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. What is a negative times any negative? Positive. Right? Now test any number between negative 3 and 3. The easiest number to test is 0. Plug 0. This is your domain number line. All real numbers. Test any number between negative 3 and 3. Any domain number. 0. Plug 0 in up here. 0 plus 3 is 0. 0 minus 3 is negative 3. What is positive 3 times negative 3? If 0 creates a negative, so will any number in between negative 3 and 3 be a negative. And look at my graph. Isn't that what my graph says? All the range values between negative 3 and 3 are negative. all the range values below -3 are positive. What about above 3? Like 4 or 4 million? 4 million plus 3 is positive. 4 million minus 3 is positive, right? Or 4, it doesn't matter. The point is, it's any number above 3 generates a positive range value. See how important domain and range are? So any number above 3 is positive. 3 generates 0. -3 generates 0. What are you asked for? What x's create numbers that are above 0? Well, here's your answer. All your x's, I want positive. So that's all my x's below -3. I want positive, so that's all the x's above positive. I'm sorry, below -3 and above +3, which is what I said right there. Okay. So the next one is also an inequality. If you can solve it with graphing, that is your best step. And I don't mean using your graphing calculator. This is an absolute value graph that has been moved right 3. Look at what the question is asking you. The question is asking you, when is this graph below 7? Right? So I just need to know when does the square root of x minus 3 equal 7? Do you see how I turned both of these inequalities into equalities once I figured out the graph? Because so I just need to know when is that true? So now I do need to do a little bit of algebra, right? I've got to solve this. How do I solve this? Remember, you learned in Algebra 2. Turn this into 2. Say, when does the x minus 3 equal 7? Or when does x minus 3 equal -7? And of course that is when x is equal to 10, or when x is equal to, add 3, -4. My graph is terrible. I'm going to fix my graph or it's going to look like it's way off. Oh, crap. because my first graph wasn't to scale. So, x is equal to -4, and x is equal to 10. That is where this graph is below 7. Notice that, unlike this problem where my answer was 2 separate pieces of the graph, this time my answers are one continuous piece. So instead of having my answer then is x is between -4 and 10. One solid shading, one statement. 2 separate shadings, 2 separate statements. Now again, if it's a graph that you're not sure about, you do your number line test, right? And you say, this time you need to know, to do the number line test though, you need to be equal to 0. So you'd have to actually say x minus 3 minus 7. When is that equal to 0? So you'd have to shift this whole thing down. So actually I think that's going to be more confusing than helpful. Here, you just need to use the graph. Okay? Or your algebra. But you gotta, with your algebra, you gotta know what the shape looks like. Alright, the next ones I grouped together are exponents and logs. These ones would be without your calculator. So if I don't have a calculator, that means that these numbers can all be written into the same base, right? So if I have 27 and 9, that better ring some bells for you. And this is where my exponent rules come into play. 27 and 9 both can be written as base 3. 27 is 3 what? Cubed. 9 is 3 what? Squared. Now, think about your exponent rules. See the base once with multiple exponents. Multiply the exponents. See the base once with multiple exponents. Multiply the exponents. Don't forget to distribute here. Once you have the same base, you can use something called the ignore property. As long as you have the same base and an equal sign, 3 to the something has to equal 3 to the something else. And all of a sudden, I'm back down to algebra. Algebra 1. Done. Whoops, sorry. Not done. And I can't combine the 6. That's a 6x. I gotta put my x's together, which means I get 4x minus 6. Subtract 2x, 4x is equal to -6. X is equal to -6/4, which is equal to -3/2. want you to notice that the next one I have an issue with. I still don't have a calculator, and I freaking have E. That makes me nervous because E is an irrational number, and I'm supposed to solve for X without a calculator. So, notice that here I had exponents on my equal sign. I had a 27 and a 9 on both sides. Here I have an E on one side, which is an exponent, but no E over here. So I'm not this one. My strategy was to rewrite to the same base because I had exponents on both sides. Here I only have an exponent on one side. This strategy isn't going to work. Exponent on one side. So I can't use the rewrite in the same base. So what I'm going to do is just try to isolate the exponent part, get it all by itself. And now I have to use some log rules. I have to use and remember the fact that logs are exponents. And I've got to translate this into logs. The exponent. Logs are exponent. The exponent that turns E into 3 is 2x. Remember, my job is to solve for x. Notice x was up in exponential land, and logs got it down. We don't write this way, though. We write it like this. Get x by itself. You're done. You do have to know your log rules and your exponent rules, because this is not going to be a calculus problem. It's going to be the end of a calculus problem. Now, just to make matters worse, I want to show you if this is a multiple choice answer, what if this isn't there? That might be there. Do you know what else might be there? This is another log property. An exponent in front of logs can be turned in, a coefficient in front of logs can be turned into an exponent on the argument of the log. Then, look at this. An exponent of 1/2 is really a radical. What if that answer is in multiple choice? I had to go through all the different ways I could rewrite this answer, even though this is the correct answer. It wasn't in multiple choice. This one was. That's why your prerequisite classes should have drilled you on rewriting and simplifying lots of different ways. All right, now let's go attack this log problem. Notice that this had exponents on both sides. So I just worked with rewriting the same base and then got myself to the ignore property. This had exponents on one side. I had to isolate the exponent and then use logs to get x down. This is a log equation, but there's logs only on one side. So I have to not isolate logs, I have to combine logs. And then use exponents. See the correlation there? So you have to know your log properties of see the log twice with addition in between, write the log once, and add. So log x plus log of x minus 3 is the same as, I'm sorry, I said add, multiply. Now remember, when there's no base down here, it's the common log. The exponent that turns 10 into x squared minus 3x is 1. And now I'm down to algebra 1. That's not my final answer. I need algebra 1. X squared minus 3x minus 10 is equal to 0. That means that x minus 5 and x plus 2 are equal to 0, which means x must be equal to 5 or x must be equal to negative 2. The domain of logs is x is greater than 0. You're not allowed to input negative 2 into a log. So you only have one answer, and that's x is equal to 5. All of this is at the end. You've been doing a bunch of calculus up here. Then you get down to this problem, and you've got to go through all your prerequisite math with your log rules, your exponent rules, your algebra 1 rules, your quadratics, and then back to cycle back to the domain of logs. Right? It's no joke, but it's doable. Just takes a lot of practice. Now, I didn't give you a problem like this, but if I had given you, right, this one, these two problems are alike. Let me give you a log problem that is similar to I. So what if I had log x plus log x minus 3 is equal to log 10. Since you have logs on both sides, I still have to combine these two logs. So I would get log of x squared minus 3x but now, since I have logs on both sides, I can just use the ignore property. Okay. Now, that really is the exact same problem, isn't it? because the exponent that turns 10 into 10 is 1. That's why you got the same answer. Oh, snap. All right. If you're going to AB calculus or standard level math next year, this is the last page of the summer packet you need to work on. The calculus test is not a trig test, so you don't need to know every freaking trig identity that you learned in pre-cal, nor will you ever have to do proofs of trig identities. Remember those? And of all of these problems, I just need you to know the ones that are most commonly helpful in calculus. These 3 are the most helpful identities. There's going to be times when you're doing calculus and you can simplify an expression that has sine squared x plus cosine x, and you can replace it with a 1. That's awfully nice. This comes from the equation of your unit circle. There are times when you're going to do calculus and need to do calculus with sine of 2x, and it's going to be very difficult, but it will be a lot easier if you replace sine 2x with 2 sine x cosine x. Now in pre-cal we proved why this was so. You don't need to know the proof. If you doubt me, graph these. Put sine of 2x into y1 and 2 sine x and cosine x into y2. Graph them and you'll see that there's the same graph. Cosine 2x doesn't come up as often, and it's a little less useful because there's 3 different identities that go with this. It could either be cosine squared x minus sine squared x. It could be 2 cosine squared x. Minus 1. I have to look these up because I don't use this cosine 2x. I shouldn't have even highlighted it. It doesn't come up that much. So honestly, these are the 2 for calculus you need to memorize. This comes off a little bit more often in multivariable calculus than it does in single variable calculus, which is AP. 1 plus tangent squared is equal to secant squared, and cotangent squared x plus 1, or 1 plus cotangent squared x, is equal to cosecant squared. Again, those 2 don't come up very often. This one comes up every so often. These 2 come up a lot in calculus. Just as a side note, these 2 are easy to show. Why? These just take some half-angle manipulation stuff. But if I write sine squared x plus cosine squared x is equal to 1, and I divide everybody by cosine squared, which is legal, right? I did the same thing to one side as I did the other. This is tangent. Cosine squared x over cosine squared x is 1, and 1 over cosine squared is secant squared. I can do the same thing for this by just dividing by sine squared instead of cosine squared, and you'll get this identity. So it's just not that, but they just don't come up as often as sine squared plus cosine squared and sine 2x. All right, so So again, if you're going to AB or standard level IB math, you're done with your summer packet. If you're going on to BC and then to higher level math, you will do the next 2 pages and you'll have the videos to go with it.